Hello everyone and welcome to .NET Core Central. In today's video, I'm going to talk about another feature of Coravel, and this time I'm going to talk about caching. In my last couple of videos, I have discussed a couple of features of Coravel. In first video, I discussed about how we can use Coravel for scheduling job and how easy it is to create some sort of schedule. And in the video after that, which is the last video I did, I talked about how we can use Coravel for queuing jobs and executing them off of the queue. In today's video, I'm going to talk about caching. Now, the caching in Coravel is very similar to any other caching framework. It supports both in-memory and external database-based caching. For database, it has some out-of-the-box drivers, as well as you can write your own custom drivers to databases that are not supported out of box by Coravel. So for adding caching into your application, you can use builder.services.add-cache, and this is going to add the caching framework into the dependency injection. And next we can use the iCache namespace, which is part of coravel.cache.interfaces, for adding and getting cache data. So for the purpose of that, I'm going to create a new API endpoint. I'll say app.map.get. Instead of the weather forecast, let's name it as just cache. And here, for the input parameter or the dependency injection, what we are going to do is we're going to add the I cache, which is part of coravel.cache.interfaces. And we're going to keep this as an async method because we are going to use a couple of async method from the Coravel caching framework. So first what we want to do is we want to add something to cache. So let's do cache dot remember is the method. So we can use remember or remember async. The difference is remember is used with a key and a function or delegate which returns a type. So it can be string or any other object which will be cached and a time span. Whereas remember async is same thing, but in this case the function or the delegate is going to return an asynchronous data. So first let's start with just remember, and let's add a key, s key, and for value we are going to just return sync value. And for the last parameter, instead of 10 seconds, let's make it 30 seconds so that we can see the value getting cached. And finally, we can do a return await cache dot get async. And since we are returning string, we are going to take the type or pass the type as a string here. But before that, what we want to do is we want to check if the cache already exists, then just return from cache and don't add it, right? So for that, what we can do is we can use the cache.exist async. Let's, it is not exist async, it is has async. We're going to use that. And if it has, then we're just going to return here. It has a not. So if it exists, then we'll just return it from the cache. That's what we're going to do. Or we could have checked if it does not exist, then remember and then return. So there are two ways of doing it. So if I just get rid of this code, just write it differently. If I say if it does not exist in cache, then add it to the cache. Otherwise, just directly return it from cache. I think this is a simpler implementation. So now that we have it, let's add a breakpoint here and let's run this application. We have an error. I'm missing some code here. Let's run the application now. And once the application is started, We have the Swagger here. I'm going to come here, try it out, execute, and it comes here. First time it's not going to be in cache, so we're going to add it to the cache, and then we're going to return it, and we see the sync value is returned. Now execute again, and this time it should be in cache, so it did not go inside, so it's just coming out directly and returning from cache, and we can see the sync value. Now let's wait for 30 seconds, and then after 30 seconds when we execute, it should be going inside and adding the cache again. So it should have been 30 seconds. Yeah, we see that it's not in cache anymore, so we add it to the cache again, and then it returns from the cache. So this is the first implementation. The second implementation is similar. It just, you can use remember async, and when we have async, we can create it as async, and here can be await task.delay. Let's just add a delay and then return async data. That should pretty much be it. And I have to add await. So now I can just get rid of these. We should be seeing async data in the response because nothing else is changed. The caching should work the same way, the hash cache. So I don't think we have to work through that. So now let's execute, and we can see async data showing up here as expected. So this is how you add data. Now, apart from adding data, which is through remember and remember async, we can also do a remember forever. So if we want to remember something forever, instead of putting a time step of in the future, you can just use forever. So forever also comes with forever and forever async. So we can just do that, and there is no need for the third parameter because it just needs two parameters, which is the key and the value. So if we do that now and run it, we can see, let me put a breakpoint here. First time it's going to come through this breakpoint, but afterwards it will always return from the cache because it is caching forever. So first time it goes to this, it's run, you see async data. Second time onwards, it will always come to that because it's cached forever. But of course, we are not saving in database, which means every time we stop the process, the cache will be lost, which is expected. So this is the saving something forever. The next thing, if you want to remove a cache, so if we want to remove this cache, then what we can do is we can have, so every time, this is forever, so what we can do is we can remove the cache every time. So we can say cache dot remove async, and our key is key, and that's pretty much it. So now what's going to happen is every time it's going to remove the key, it's going to add it back, but again it's going to remove. So we will never, this condition will never be, will always be true. So we'll always add it to the cache because we are removing before. This is not how you are going to do, but this is just to show how to use the remove async. So let's run this. We have a problem. Remember, oh, I said remember async. I had to say for, I had to say forgot, and it is not anything, so we don't need an await. So now what we can do is run this application. And now if we go back to cache and try it out, execute, it comes here. It's not there, of course, first time. It's adding to the cache, returning the data. We see the data here. We execute again. Again, this will say, oh, I don't have it in cache, because we are forgetting every single time. So this goes to show how we can use forget. Now, apart from forget, here we are forgetting a specific key. But if you want to flush everything, the name is very intuitive, which is flush. It flushes the entire cache. So now let's try the same thing out, and we'll see that every time it will not get anything in the cache, and it will try to add it back into the cache. So go here, cache, try it out, execute. Well, it's not there, which is expected for the first time. Execute, now also it's not there because we just flushed the cache again. So as expected, we every time we try to hit it, the cache is not going to be here because we flushed. Now let's talk about the database drivers. Comes with separate NuGet packages. So let's go to the NuGet package manager, and let's search for in the browse. Let's in the browse, let's search for Coravel.cache, and here we see that it has a SQL Server cache, which is supported. It also has a Postgres cache. So these are two caches which are supported, and this is the database.core, which is used by both these caching framework. So if you have to add yet another database, you can use the database core and then build your own cache. So this is the two database caches which are available out of box. So writing custom driver, I think we can write custom driver by implementing our own cache driver, our own cache class, by extending the or implementing the iCache interface. So if we have to create a cache, we can say and then implement the interface, and here we can write whichever way we want to, and then of course we will have to add this to the dependency injection, in which case we don't have to. So let's say this is what we want to implement for our caching. So in this case what we can do is everything is going to throw a not implemented error. So if we just go here, get rid of this cache, and say this, now iCache will represent the my cache. If for the flush, let's not throw an error. Let's just do some console dot write line flash. For everything, let's just do console. And for these ones, I have to, and that's what we should do here also, because the function is already provided. And this one, let's keep it not implemented because it's a little bit time consuming to implement. So I'm just going to leave it. So now if we run the application, we should see our extension class, which is mycache. But in case of mycache, we can connect to Redis or or memcache or any other storage for that matter, MongoDB, whatever we want to do, we can do it. So if we do flash, let's see, it goes into flash and execute my flash, goes to hash key, it is not implemented, so it's going to throw an error, and we are going to get the error here as expected. So that is all I wanted to cover for today's video. If you like this video, please give it a thumbs up. And if you are new to this channel and you think you are getting value out of this channel, please subscribe to the channel. And thanks so much for watching this video.